This question says AB is the diameter of a semicircle. Point P has coordinates P3 and A and lies on the semicircle. Find the value of A. For part A, we have to find the value of A here. For any semicircle, we know the point in the circumference or which subtended in two others. Circumference of this semicircle would be, the angles here would be 90. So for triangle A, P, B, I have a right triangle. And for right triangle, I can use Pythagoras theorem. Pythagoras theorem says if I get it, hypotenuse, which is uh, opposite the angle of 90, I get it, hypotenuse. Hypotenuse to the power of 2 equals the other side, the sum of the other sides to the power of 2. So I say hypotenuse, which is a b to the power of 2 equals pb to the power of 2 plus ap to the power of 2. ap to the power of 2. Now I find the length of these sides. AP, we know the distance between 2 points, AP, distance between 2 points, follow the formula that says the square root of the difference of x to the power of 2, that means 3 minus 5, 3 minus negative 5, 3 minus negative 5, which gives me 3 plus 5, which is 8 to the power of 2, plus a minus 0, that's a to the power of 2. I will go for PB. PB again, follow this rule. So I say the difference of x to the power of 2, 3 minus 5 here, which gives me 2 to the power of 2, which is 4. So 4 plus, now a minus 0 to the power of 2, which is a to the power of 2. Now I will go for the distance or the length of AB. If I say AB is the diameter of this semicircle, we know if I get here this origin, which is 0 and 0. So if I find the distance here, which is 5 minus 0 to the power of 2, which is 25, and 0 minus 0 to the power of 2 gives me 0. Again, I will get 5. So this distance would be 5. That's my radius. So the diameter would be 10, twice the radius. But I can find this distance here, which says 5 minus 5 to the power of 2, which is 10 to the power of 200, and 0 minus 0 to the power of 2, which is 0. So it's a square root of 100 gives me 10. So I will write it here. AB is 10. Now I substitute the value that I find here to this formula of Pythagoras theorem. Let me change my color. So I substitute this value in this formula. So I say AB to the power of 2, which is 100, equals PB to the power of 2 here. And so I will get rid of this square root. So it would be 4 plus A to the power of 2 plus AP to the power of 2. So give me 8 to the power of 2 gives me 64 plus A to the power of 2. Now I collect all the variable here, which is 2A squared to A squared equals, and bring 68 to the left side. I organize and write variable in the left side and bring all the constants in the right side. So I will say 100 minus 68, which gives me 32. It would be 32. So I write A squared equals 32 divided by 2. To get rid of this coefficient of A, I divided both sides by 2, which is 16. And take a square root from both sides. So A would be positive or negative 4. But here, as we see, that's A located at the positive side of this y-axis, so I get it positive. So it would be positive 4. So the coordinates of P is 3 and 4. I will go for part B that says find the gradient slope of line segment AP. Here we know the slope or gradient would be the step of y equals the steps of x. So I say y2, which is 4 minus 0, minus y1, which is 4 minus 0, over x2, which is 3, minus negative 5 gives me 5. So my slope would be 1, 4 over 8. If I simplify, it would be 1 over 2. It's for m of a p. Let me write a p. Now I will go for part 2. Part 2 says line segment BP. Here I am gonna find gradient of this line segment. So I write m equals, again, a step of y over step of x. So I will have y2 minus y1, which is 4, and x2 minus x1, which is 3 minus 5 is negative 2. So I have 4 over negative 2. If I simplify, gives me negative 2.